So we'll be starting the third session. But before starting the third session, I have an announcement to make. All the G&G reviewers and all the PAPG as XCOM and their subcommittees are requested to please attend the gala dinner tonight, as you will be receiving your shields over there before the musical program after the dinner. So it is requested to please come to the dinner after this program. All the reviewers. This is for all the G&G reviewers especially. Thank you. So moving toward the third session, I would like to invite our distinguished chairperson, Ms. Dr. Khalid Amin Khan, to please come on the stage. Thank you, sir. And I would like to invite Dr. Sajjad Ahmed to please come on the stage. So before proceeding ahead, I will be giving a brief introduction about both our esteemed chairpersons. As we know that Dr. Khalid Amin Khan is currently working as GM Geological Services. Previously, he has worked in Seismic Data Processing Center as well as Prospect Generation Department of OGDCL. He is an active member of Society of Geophysicists, American Geophysical Society Union, and Fellow of Royal Astronomical Society. And we all are well aware about the contribution which he has done amongst the software development, indigenous software development of Pakistan. So I need a round of applause for him. Dr. Sajjad Ahmed, who is a recipient of the Lifetime Achievement Award in our last ATC. He currently holds the position of Director General, GSP. In this role, he provides executive leadership, strategic direction, and overall management of the organization. He has worked as a member of the Board of Directors of Government Holding Private Limited and Sandak Metal Limited. Prior to joining GSP, he has served for about 28 years as a professor and chairman of the Department of Geology, University of Peshawar. In addition to his management and operational role, he has successfully researched and published more than 40 research papers in national and international journals, 2 book chapters, and 25 professional reports addressing the geological problem and hydrocarbon potential of Pakistan. Dr. Sajjad and Dr. Khalid, it's a pleasure and an honor of having you both here as our chairperson. And we, on the behalf of PAPG, thank you very much, sir. So before I call in the next person, again, I would like to request all the presenters to stick to your 20-minute schedule. Otherwise, the bell would ring because we have a very limited time slot, and you can see that things are proceeding on ahead. So for a seamless session, we need at least 20 minutes per session. Khalid sir?
I would like to invite the presenter, Mr. Ali Iqtidar, to deliver his talk on the third block 2 lignite resource estimation using 3D block modeling and graded seam modeling techniques. Mr. Ali Iqtidar is currently working with Sindh Angro Coal Mining Company as Manager of Geology and Hydrogeology. Ali Iqtidar completed his master's degree in geology from University of Karachi. He is associated with SECMC since 2016 and played a vital role in development of Pakistan's first open pit coal mine. Ali has published multiple research papers and articles in national and international journals and magazines. He was involved in GORC certification of Third Block 2, resource modeling and its upgradation, groundwater modeling, geotechnical modeling, and slope stability studies of first ever open pit coal mine of Pakistan. In addition, he has completed certification of GORC code reporting AUSIMM. So, Mr. Ali Iqtidar, please.
Thank you, sir, for the introduction. So we have talked a lot about petroleum since this morning, and we will be talking more and more in the next one day. But let's talk a bit about Thar coal. So my topic for the presentation is Thar coal lignite resource estimation using 3D block modeling and gridded seam modeling techniques. So these are two different modeling techniques, and we will compare these techniques and the results and outcomes based on it. So this is the table of content. First, I'll give a brief overview of the Thar coal. Then we will discuss about the study area, our exploration and drill hole database, the results, the modeling techniques, and then the outcomes and conclusion. The picture in the background is our Thar coal mine. This is the first and the largest Thar coal open pit mine of Pakistan, which is producing currently 7.6 million tons per annum of coal, and is based on that coal, we are producing around 1300 megawatt of power annually. So this is the lignite deposit. It is the 6th largest lignite deposit of the world also. So we have different coal deposits all over Pakistan. We all know about Lakhla coal deposit. We have some in Badin, in the northern part as well, in Salt Range, in Charat. But we have the most dominant Thar coal deposit in Pakistan, which contributes to around 94% of the overall coal reserves of Pakistan. So we have around 186 billion tons of Pakistan coal available, and out of that 186 billion, we have 175 billion tons in Thar. So this is the overview of our study area. The Thar coal is located at the southeast part of the Pakistan. In the Thar region, we have around 14 Thar coal blocks, and out of those 14 Thar coal blocks, 2 of them are in operation. We as Angro are working in Thar coal block 2 in this black border line, and we have been operating since 2015. Another block which is in operation is block 1, which is being basically operated by a Chinese company. So out of those 14 blocks, 2 of the Thar coal blocks are in operation and producing coal to power the grid. This is our project expansion plan. We have 4 different phases of our project. The first phase was started back in 2016, targeted to produce 3.8 million tons of annum coal production. And we achieved our COD commercial operations date in July 2019, and since then we are producing 3.8 million tons per annum of coal. In parallel, we started our phase 2 of mine expansion in 2020, and we achieved our COD for phase 2 in 2022. This phase involves the coal production of around 7.6 million tons per annum, and this is our current phase of production. We are also expanding the mine to phase 3, which is 11.4 million tons per annum, and we are planning that we hope to achieve the commercial operations date for phase 3 by Q1 2024. We are also working on the feasibility of phase 4, which will provide coal to cement industry, and also we will work on the conversion of coal to gas. This is just a brief stratigraphy of the Thar coal. Starting from the bottom, we have granite deposit, Nagapaka granite. This is the oldest rocks we have on Earth. Then after granite, we have an aquifer body of around 30 to 40 meters thickness. Then we have the coal bearing formation, which we call the Bada formation. Its age is Paleocene to Eocene. Above the coal bearing formation, we have another aquifer layer, which we call as the coal seam roof aquifer. Then we have two different formations of waste. One is the subrecent formation, and the topmost formation is the dune sand. The age is recent. In the Bada coal formation, we have different coal seams available. So we have three different groups of coal seams. The uppermost, or the first group of the coal seam, has the relatively low grade coal quality, but the middle coal seam has the greatest and the very good coal quality available. The third coal seam and the third coal group, or the bottommost coal group, is within the aquifer zone, so it is non-mineable. This is the map of our block 2, which is our lease area. The red line is our block boundary. In this block boundary, we have around over 200 drill holes available. So based on that drill holes, we extracted samples on we have around more than 2,000 samples available from our block, and we used those samples for the development of resource model. So we also have some input samples available because in the mine the coal benches or the coal walls are exposed, so we can grab samples from the coal walls directly as well. So we have over 1,500 coal samples from the benches available for the model development. So this is the different distribution of units. Like I said that we have three different formations. First one is the recent formation. So we have divided this recent formation into three different waste units. The second formation is the subrecent formation. This formation is also divided into several waste units, and the third formation is the coal bearing formation, and this formation is divided into different coal seams and the interburden units. Interburden is the waste material which is located in between the coal seams. So on the right side of the slide, we have the model quality items. We have around 20 quality parameters included in our model, starting from moisture, ash, volatile, calorific value, sulfur, fixed carbon, and all the ash composition. So this is the brief process flow of the model development. First of all, again, like in the petroleum industry, we similarly we do the exploration and the drilling to grab samples from the subsurface. Then we run the geophysical logs to confirm our lithology or the lithologs, and then we send the samples for the assay testing. Once we get the geophysical and the assay data, we develop a database, and then the database is used to develop the model. So we then import the database into a 3D software. Then we model. First of all, we have to model the structure. The structure means that the coal seams lateral extent. So once we model the coal seams or the structure of our model, then we move on to model the quality aspects of the deposit, and then we based on the structure and the quality data or the model, we do resource estimation and reporting. So this is just a few snapshots of our structural model. Like you see, this is the drill hole, and these are our three different coal seams. So we have during structural modeling, it is important that the top and the bottom surfaces of our structure must honor the drill hole. So like you are seeing, like you can see in the picture, that the top and the bottom surfaces are honoring the drill hole database. So this is just a small snapshot of our structural model. So moving to the next. So these are two different types of resource modeling techniques. One is the 3D block modeling technique, in which we divide the deposit into blocks. In both the techniques, we will divide the deposit into blocks, but in the 3D block modeling technique, the Z part of the block, the vertical length of the block is it does not depend on the seam thickness. It is basically it divides the block on fixed length basis. So you can see that the blocks are of same sizes. All the blocks are of same size, and they are not depending on the seam behavior or the seam thickness. Whereas the next technique, the graded seam model technique, it honors the same thickness. The blocks honors the same thickness. It depends on the same thickness, and it follows the same trend. So this is the difference between these two modeling techniques, and and we have to decide that what type of modeling technique is useful for us. So for a deposit like Thar, we usually prefer to go for graded seam modeling because homogeneity in terms of structure and quality in Thar coal deposit is very uniform. The quality parameters is very uniform, so we usually prefer and usually go for graded seam modeling. So this so these are the results based on both the modeling techniques. If you can see the moisture values between graded seam model and the block model, these are our coal seams. So the average moisture does not vary a lot in both the models. The quality parameters, if we talk about moisture, ash, QNet or sulfur, they are more or less similar, but there are slight variation in terms of tonnages. So the graded seam model, because of the fact that it honors the seam thickness, provides a more realistic tonnages of the deposit. So the conclusion is the graded seam model, since it honors the drill hole and it performs seam constrained compositing, is more preferred modeling technique for Thar coal. For ore deposits, we can select 3D block modeling techniques, which may be helpful, but for Thar coal, we prefer graded seam modeling. This is all from my side. Thank you. If you have any question, please feel free to ask.
Thank you, Ali Iqtidar. Audience, please, if there are any questions.
Okay, for the next paper, I would call Ijaz Ali. He graduated in 2014 and earned his MPhil degree in geology from University of Sindh, Jamshoro. He worked with Petro Services Pakistan branch as mud logging engineer from 2014 to 2017. Then he joined College Education Department, Government of Sindh, as lecturer of geology. He joined University of Sindh, Jamshoro in 2022 as field supervisor, and currently is engaged with his PhD research in the field of structural geology of fold thrust belts, with special focus on cross-section balancing and restoration, active deformation, remote sensing, seismic interpretation, and role of structural geology in energy transition, with special attention on the storage of energy in geological structures. The title of his paper is Microfacies of Nari Formation from Hyundai Anticline, Karachi, embayment southern Indus Basin, Pakistan.
Thank you, sir. Assalamu alaikum. I am Ijaz Ali Halepoto from University of Sindh. With the permission of chair, I am here to present our research paper with the title Microfacies of Nari Formation from Hyundai Anticline, Karachi embayment, southern Indus Basin, Pakistan. And these are the co-authors of this research paper. Next thing, These are the contents of this presentation. Going to the introduction. Present study area is located in the Karachi embayment, southern Indus Basin, Pakistan. Basically, Indus Basin is located on the northwestern margin of Indian plate. And the western margin of Indus Basin was folded, deformed and folded during the collision of Indian plate with the Eurasian plate. And therefore, regional fold belt chain known as Himalaya, Suleiman and Kirthar fold belt chain was developed. Suleiman fold belt basically is located in the western part of central Indus Basin, and Kirthar fold belt is located in the western part of the southern Indus Basin. So Karachi embayment is the southernmost unit of this regional Himalaya Suleiman Kirthar fold belt chain. The Oligocene strata are widely distributed in the Kirthar fold belt part of the Indus Basin, which are here known as the Nari Formation. Nari Formation is basically primary reservoir target in the offshore Indus Basin as well. And this is the location map of the study area. This line shows the outline of the Karachi embayment, and this is the location of the Hundi anticline, and this is the regional structural framework of the southern Kirthar fold belt. So this is the stratigraphic column of the study area. As all days talks about the Nangar Park Igneous complex, and the Paleozoic sequence is not yet drilled or exposed from the southern Indus Basin. And all these other stratigraphy either is encountered in the drill holes or it's exposed on surface, and the petroleum elements of the study area are also shown over here. And these are the key decollement horizons are present in the Kirthar fold belt particularly. And these are the different tectonic events of the Indian plate from right from the Paleozoic to the recent. So Karachi embayment is basically developed due to the abrupt downwrapping of the outer shelf of Indus Basin during the Mesozoic rifting of Indian plate from the rest of the Gondwana fragments. And Karachi embayment is a unique tectonic element in the tectonic framework of Pakistan because it contains conformable Cretaceous and Tertiary formation, Cretaceous and Tertiary contact. And it contains thickest Paleocene strata in the Indus Basin, which are encountered in the different wells of Surrey gas field of the OGDCL. And the Karachi embayment also exhibits the last marine sedimentation in the Indus Basin. The marine carbonate deposition at as late as up to the Miocene to early Pliocene are recorded in the Karachi embayment. And mostly Karachi embayment contains exposures of Eocene and younger rocks, which are folded in the north-south trending anticline and anticlines. This is the geological map of the study area. The axis of the Hundi anticline goes over here, and the studied section or measured section is located exposed along the eastern flank of Hundi anticline. So this is the workflow of present study. We conducted the geological fieldwork to measure the stratigraphic section. We compiled the graphic sedimentary logging by identifying different lithofacies of limestone, sandstone, and shell. We collected different samples of different lithofacies, and we prepared thin sections from well compacted and hard samples. And we analyzed these samples under petrographic microscope. We evaluated their texture, mineral composition, and microfossil assemblages. And during the petrography, we identified different microfacies. We compared these microfacies with the standard microfacies of Wilson and Flugel. And the depositional environment of these microfacies was interpreted on the basis of microfossil assemblages and the textural attributes. And then a sequence of depositional event was compiled. So these are the different field photographs of the studied section. Over here we are measuring the stratigraphic section of the Nari formation by tape and Brinton method. And this is the last arenaceous limestone unit of the studied section. These are also different field photographs of the studied section. This is basically a Hundi anticline, and this is a core of anticline over upper Eocene Kirthar formation is exposed, and which is overlain by Nari formation, which we measured during present study. And these are also the field photograph of arenaceous limestone lithofacies. This is oxidized sandstone or laterite unit within the Nari formation in the study area, which is overlain by this fissile shell. So this is again the field photograph of oxidized sandstone. The stratigraphic position of this oxidized sandstone unit in the Nari formation is over here, and these basically two shell units are the fissile shell units which we seen in previous slide. So these are the photograph of petrographic lab of Advanced Research Lab Center for Pure and Applied Geology, where we carried out the petrography. And this is the ternary diagram for the classification of mixed carbonate clastic rocks. Basically, Mount classified the mixed carbonate clastic rocks on the basis of relative proportion of allocames, sand, and micrite. So we plotted the identified textural attributes of the Nari formation on this plot. So we identified 3 lithofacies of sparse biomicrite and 5 lithofacies of the packed biomicrite. So during petrography, we identified 7 different microfacies assemblages on the basis of allocames, micrite, siliciclastic, and the lowermost microfacies of the Nari formation are rich in larger benthic foraminifera, and the concentration of fossils decrease from the bottom to top. This is the textural composition of the Nari formation. The NMF1 is the standard microfacies of the Nari formation, which is the oldest position located over here. And this is the NMF11, 11 numbers, NMF7, 7th microfacies composed of the calcareous sandstone, and this is located over their top. And this is the relative proportion of the allocames, micrite, and sand in the microfacies, and these are the classification names after the mount. So this is the microphotograph of first and second microfacies of the Nari formation. The microphotograph of A, B, C, D, and E belongs to the standard microfacies 1, which is here named as NMF1, which stands for the microfacies of Nari formation. So basically, this microfacies is rich in discocyclina, larger benthic foraminifera. These are different species of the discocyclina, and discocyclina are observed in the outer to middle ramp depositional environment, and these microfacies is also rich in the allocames. Very rare or little percent of the micrite and sand is observed in these microfacies, and the stratigraphic position of NMF1 is here and here. So these microfacies are believed to be deposited in the outer to middle shell, middle ramp, and the microphotograph of F, G, H, and I belongs to the NMF2, which is a microfacies of Nari formation number 2. This microfacies is composed of sparse biomicrite, dominantly composed of micrite, with rare skeletal fragments, and this is a spericalcite basically, and calcite veins can also be observed over here. These microfacies also contains some traces of gluconite and pyrite. So the dominancy of the micrite indicate the very slow deposition, very low energy deposition conditions, and the presence of the gluconite is also indicator of very slow deposition rate. So therefore, the deposition environment of microfacies number 2 is interpreted to be inner ramp to the lagoon. And the stratigraphic position of second microfacies is shown in these green colors. This is the third microfacies of the Nari formation, which is named here as bivalve algae packed biomicrite microfacies, because a variety of microfossils is identified in these microfacies. As we can see here, this is a Miliolina, Rotalina, this is a Fusilina, so Alivolina is algae, Operculina, Nummulitis, and this is also algae, Ostracotes, Gardrina, Miliolina, Triloculina, Ostracotes. These are all different microfossils of the foraminifera and other animal groups. And there is another also image. This is basically bivalve. This is bivalve observed also in this species number microfacies number 3. So abundance of these microfossils and dominancy of the allocames in this microfacies indicate these microfacies are deposited in the middle ramp, and this is the stratigraphic position of these microfacies within the Nari formation. This is the photograph from H to M belongs to the NMF4, which is Acylina operculina packed biomicrite macrophages, because these macrophages are rich in the Acylina, operculina and pneumolitis. These different photographs of Acylina can be seen over here, and this is operculina, this is also operculina, and these are others. This is also operculina, and these are the other microfossils. These microfossils are also observed or identified worldwide in the middle shelf or a middle ramp depositional environment. So therefore, the deposition environment for fourth macrophages of Nari formation is interpreted to be the middle ramp depositional environment, and the stratigraphic position of the fourth macrophages of the Nari formation is shown over here. These are the fifth and sixth microphases of Nari formation, which are basically composed of the limestone and dominantly sandstone. The percentage of quartz significantly increase in the fifth microphases, but some rare fossils of Miliolina and Camerina can also be seen, are also observed in these microphases. So these microphases are interpreted to be deposited in the inner ramp. The photograph of C, D and E are basically the sixth macrophages of Nari formation. These are the sandstone dominantly composed of feldspar and quartz, contains some fragments of algae. These are the algae, and the clay minerals and iron bearing minerals can also be observed in these macrophages. And the stratigraphic position the stratigraphic position of fifth macrophages can be seen over here. Over here, and the sixth macrophages can be seen over here, which is the argillaceous sandstone. This is the last microphases of the Nari formation, which is identified during the present study. So this is basically quartz or arenite, the sandstone, which is dominantly composed of quartz with calcite as a cementing material. The stratigraphic position of this macrophages is shown over here. So this is the depositional model of the Nari formation compiled on the basis of present study. So these are this is the macrophages 1 and macrophages 1. These are deposited to be in the outer to middle ramp deposition environment. These are the deepest macrophages of the Nari formation observed in the study area, which are observed along the contact of Kirthar and Nari formation, and then the macrophase number 3 and macrophase number 4 are deposited in the middle ramp to a little bit in the inner ramp as well. And this is zone basically either marked by evaporitic depositional conditions or exposed during some beds of the marine deposition or fluvial deposition are also observed over here. And these are those deposits which are either deposited in the lagoon or in the inner ramp depositional environment. And this is the basically shelf or the ramp slope, which indicate the different division of different deposition environments, and the presence of fossils in these deposition environment. So these are the conclusion. We identified 7 macrophages assemblages on the basis of allochem, micrite and sand, which contains packed biomicrite, sparse biomicrite, subarcos and quartz arenite. And the macrophages are rich in larger benthics such as discocyclina, pneumolitis, acylina, operculina, miliolina, alveolina, and some very rarely in some samples the macrofossils of the fusulina, rotalia, triloculina, operculina, gardnerina, calcareous algae, bivalve and ostrocots are also observed. The Nari formation in the study area is deposited in the shallow marine environment from outer ramp to the inner ramp, lagoon and fluvial deposition environment. Basically, lower part of the Nari formation is deposited in the deeper outer marine in the deposition environment, and the top of the Nari formation is deposited in the fluvial to evaporitic depositional conditions. The Nari formation in the study area indicate the general shallowing up or progradational facies trend, which is attributed to the regression due to the uplifting and deformation of the northern and western margin of Indian plate. Thank you for your kind patience, and any question you can ask.
Okay, thank you. The session is open for questions.
Thank you very much. Very good presentation.
Thank you.
I have one question regarding the deposition model. Did you find any signs of shoals or calcareous sand in your area?
Sir, basically, we of course we identified the calcareous sand. There are different. Basically, all these sandstone units, sir. These sandstone units over here. I think these are 6 sandstone units. These are basically calcareous sandstone. Either, but mostly they contain calcite as a cementing material, and little bit fossils are also observed in these samples.
Did you find any ooites?
Sorry.
Ooites.
Ooites. No, sir. We during present whatsoever samples we observed during petrography, we didn't identify any ooide or pelluoide in these samples. Basically, there is another study of the Lucky Formation, Khirthar Formation. Ooides are commonly observed in these type of limestone. We didn't identify it in the Nari Formation.
Okay, one more question, maybe that is not relevant to your work. Did you classify the cements? There are early calcite cementation or late stage calcite cementation.
During present study, we didn't identify the cementing.
That is beyond your scope.
Because basically the classification of cementing is a little bit related with the diagenesis.
Yes, yes.
So here we didn't classify it.
Okay, thank you. Very good presentation.
Okay, for the next presentation, I would call Mr. Noman. He has a background with BS in sequence stratigraphy and MS in structural geology. Currently, he is serving as research assistant in National Center for Excellence in Geology. He has diverse experience of applied geology for exploration and estimation of natural resources. He dedicated his ongoing PhD research work to exploration using advanced remote sensing tools and techniques for exploration and characterizing Earth's natural resources. He has expertise in different GNG software tools through which he can model and surface the subsurface geometry of economic crustal mass. And the title of his paper is Advanced Remote Sensing Techniques for Lithological Mapping and Rock Identification, a case study from Northeast Kohar Plateau, Pakistan.
Thank you. Bismillah ar-Rahman ar-Rahim. So, the title of my presentation is Advanced Remote Sensing Techniques for Lithological Mapping, a case study from the Northeast Kohar Plateau, Pakistan. So the outlines which I will follow in my presentation are as starting with the introduction, followed by the material and methods which I have used in my study, then my result, and the conclusions. So this study basically revolves around the lithological mapping, which is a basic tool, basic task for every geologist in the field. So conventionally, it can be done very easily, but these conventional techniques have some limitation which are pointed here, like the conventional mapping technique are basically laborious, and it requires much amount of time, and money factor is also involved, and technically it is based on the point or traverse basis interpretation, so it has many room for the misinterpretation of some lithological units, and it also have a drawback of inaccessibility. In some time we have the issues of the socio-economic issue or security issues, so we cannot move to the field in those areas. So there are some pictures just to show sometime how you have to climb up in the difficult terrain, and also sometimes you have to do the hectic paperwork in the field while doing this lithological mapping. But on the other hand, what I am going to present here is an alternative tool, that is advanced remote sensing based technique. which have some perks as compared to the conventional mapping techniques, which are it is efficient and effective in terms of its accuracy. It provides us the continuous spatial coverage without any seam break. It also is time and cost effective. It is not destructive, such as in conventional techniques we have to sometime we broke the rock sample in the field, but in this technique we don't disturb the outcrop. So here is an illustration which basically show how the satellite data, which is revolving around the Earth, and it collect the how much the area it capture and how it collect or record the data. So the study area which I have choose for the study is the northeast quad plateau, which is because of its economic potential for various economic reserves like the rock salt, coal, hydrocarbon, and gypsum, etc. And here is a map which is showing the location of the study area here in this zone, northeast quad plateau in yellow color, and which is in the upper portion, upper part of the figure is showing the location of the study area with respect to the major tectonic element of the Pakistan. That is, in the north we have the MBT, in the east we have the Indus River, and in the west we have the Kurum Fault. So, whereas in the lower picture, I just wanted to show the tectonic the structural elements of the structural geometry, surface structural geometry of the study area. So, as mentioned in the title, the aim of the study is to explore the multispectral remote sensing techniques for the lithological mapping, and the objective to meet this goal is to first to do the remote sensing based lithological interpretation, then field validation of my interpretation, and in the end classification. So methodology can be categorized in three parts. Starting with the reconnaissance, which is the integral part of any research work, and it involves the literature review and consulting the published maps of the study area, followed by the second step, which is the remote sensing analysis, which involves the acquiring of the satellite data set and applying some pre-processing techniques, as the data set have some noise and some background or some extra area in it, so we have to do or apply some pre-processing techniques in this case, and after that the pre-processing we apply some transformation techniques, which is basically called as processing. And based upon this processing, we interpret our lithological variation, surface lithological variation, and after this we go to ground truth, our interpretation, which is based on the lithological geological fieldwork or short fieldwork, basically it is, and the collecting of the spectral signature of the outcrop lithologies. And based on these three steps, we classify a map and we produce a lithological map for the study area. And we also perform the accuracy assessment to check the validation or how much the accurate my results are. For this, we do the confusion matrix and other techniques. So this is a chart which shows the stratigraphy which is exposed in the study area, and in this by study area it starts from the Eocene carbonates, shales, and also some clastic outcrops of the Miocene age Rawalpindi group. So for the sake of the simplicity and to meet the goal of this research, I classified or categorized the lithologies into four classes. That is carbonate, which include the Kohart formation and Shikhan formation. The evaporite it include the Jatta gypsum, and the red clastic bed include the Murray sandstone, which are red colored sandstone bodies, and the green clastic beds are the Kamlial greenish sandstones. And here are the spectral signature of these three lithological classes. And it is this table basically shows the detail of the multispectral satellite data which I have used in my study, that is Aster. The attributes of the Aster sensor are here. You can see it provides us the 14 number of the bands, and here is if you can see the marker on the last column, you can see the spatial resolution, and in this the mid column you can see the wavelength which are detected by the Aster sensors. And in this figure, you can see, I just wanted to show the position of the spectral bands in the after sensor relative to the spectral response or spectral curves of the lithological classes, which I am going to map in the study area. And the purpose is that I can select the most suitable bands which can detect the more relevant information or more characteristic signature of the lithologies which are going to be mapped. Now, here are some results which I have derived by performing this analysis. So, starting with the basic composite of the reflectance data of this satellite result. So, it is based upon the RGB colors of different specific bands, and where you can see the surface distribution of these 4 classes. You can see the carbonates are highlighted in the yellowish color, the reddish sandstones are visible in the dark gray, the greenish clastic rocks are visible in the blender of brownish to light gray color, whereas the evaporites are showing the are visible in the pinkish color. Similarly, I perform some image transformation techniques, which are the PCA, MNF, and band ratio technique. These are basically in the background. The statistical conversion is involved here, which do the some statistical conversion to the background values of the each pixel, and by doing so, it decreases the noise and it increases the information or variability within the data. So you can see here is a result of a PCA composite, where which is showing the surface distribution of these rocks very beautifully. You can see the carbonates are highlighted in the purplish color, the murky sandstones are highlighted in the yellowish color, and evaporites are visible in the sky blue, and the green classic cameleal beds are visible in the blender of bluish to green color. Similarly, MNF technique, it also very beautifully display the surface distribution of these lithologies. You can see here the carbonates are again highlighted in the purplish color. The evaporites are highlighted in the somewhat navy blue color, and murky formation is highlighted in the dark parrot green color, and the green sandstones are highlighted in the blender of sky blue to greenish color. After that, there is another technique that is called band ratio. Band ratio technique, basically, it is designed to extract or to highlight a specific mineral based upon this selection of the specific wavelengths or specific bands. So in the first, I apply the calcite band ratio technique, which highlighted those outcrops which have the potential or which have the percentage of the carbonates in it. Those pixels or those outcrops are highlighted in the brighter pixel. You can see in this, all the brighter shades are basically the calcite rich zones. Secondly, I applied as my study area or background or literature review show me that here are the classic sedimentary rocks which are enriched in the quartz minerals. So I also tried out the quartz band ratio, which also shows the surface distribution of the quartz rich lithologies. Similarly, then I apply another technique for the sake of highlighting the murky-rich or the iron oxide minerals. I applied the iron oxide band ratio, which highlighted the iron oxide-rich zones in the brighter color. And in the end, I make a composite from these three band ratios, and which also exhibit the distribution of these lithologies in a colorful way. You can see the carbonates are highlighted in the pinkish to bluish color. The evaporites are highlighted in the dark color. The murky formation is giving the blender here a blender of brownish to reddish color, and the green classic beds are highlighted in the parrot green color. So up to now, this was my interpretation based upon the remote sensing data set. The next step, what I did is to validate this interpretation. So for this purpose, I visited the field area, and what I did, I identified the surface outcrop of the various lithologies, and I also collected the spectral signature of each lithological class through the radio spectrometer device. So here are some field photographs which is showing the collection of the spectral signature of each lithological class, and here is in the upper curve you can see the spectral signature of each lithological class, and in the down this curve I categorize, or I gathered the similar lithologies in the same class. So after doing my fieldwork, what I did the comparison of the spectral signature from my fieldwork and the spectral signature of this each of the satellite data set. Here you can see I plotted the spectral signature of each class. The dotted line is showing the spectral signature of this class resampled from obtained from the radio spectrometer device in the field and resampled to the scale of or spectral resolution of the Astra sensor to have the more suitable comparison. And I noted that all these pixels are showing a very good match, spectral match. So I use this spectral signature for the classification of this study area or this satellite image. And I applied the technique I applied is the SAM classification, and based upon this classification technique, I basically prepare a classified lithological map based on the remote sensing techniques. And I also perform the accuracy assessment of this map based upon the confusion matrix, and it gives me the accuracy, overall accuracy of the 76% and Kappa coefficient of about 67%. So in the end conclusion, the conclusion can be summarized in the 4 point. The Astra dataset, number one, the Astra dataset has the potential to map the major lithological classes, and whereas within the Astra satellite sensor, we have the VNIR and SWIR bands, which have the more power to detect this lithological identification. And the techniques which I have used are including PCA, MNF, BR, band ratio. All of these three techniques are very suitable for detecting these lithological variation in the area. And what I interpret or what I identify that the crystalline lithologies are reflected in the more clear signatures, whereas the sedimentary lithologies are giving very dull shades. Whereas the SAM classification is also tested in this study, and it suggests that it is a very good tool to classify or to prepare a classified map of the study area. Thanks.
Okay, thank you for a nice paper. Session is open for questions.
Assalamu alaikum. I have a question regarding you have used PCA or the false color composites and also the band ratios. You have shown different, of course, these satellite images, but I can't see over here that which band ratios means particular band ratios which you have used. And for the and there was another image. Which type of bands you combined to create a false color composite?
False color composite, basically it is based upon the untreated or untransformed data set of the satellite. I just selected those bands based upon my observation of their spectral signature, in which I have used.
Yes, this one.
You can observe in this figure, you can choose those bands which are regarding the more dips and which are regarding the more variation in the spectral signature of each lithologic classes. So here, if you can observe, you can see that in the short wave infrared region you have the more control of the detection. So I have used the short wave infrared bands for making the false color composite. And the second question regarding the band ratio, so it is for this purpose you have to observe or you have to go for the spectral signature of each mineral you are going to target, and then look at your data that which bands are detecting those signatures, and you have to choose that bands.
Okay, basically I try to ask that basically we have 3 channels in ArcGIS because
Yes.
we can only show 3 color bands in the RGB pattern, and there are 14 different channels of spectral range of the STR satellite image.
Yes.
So I am basically asking that which three channels or which three bands are used or combined to create a false color composite, and the other thing is regarding band ratios, because we have to choose any two band channels to create a single band ratio, and we have only three channels to give three band ratios. So basically, there can be multiple band ratios can be used over there, and there can be multiple channels which are combined to create band ratios. But in these images, I can't see or probably that which basically which those three band ratios or which those three band channels have you used to create a false color composite.
I don't want to disclose here because it is a part of my PhD work, so I will be going to publish it.
So
But I give you the idea. This is the key. The chart I showed here. This is the key. You have to search for yourself that if you are going to highlight or you are going to map carbonate rocks, so you have the spectral signature of the carbonates in the blue color, and you have the distribution of the Astra sensor wavelengths. So you can select the most relevant bands.
It is not question, it's a suggestion that you use Astar sensor, but the Landsat and Sentinel and other satellites are also present with very fine resolution, I think, of at least of 10 meter resolution,
Yes.
because Astar has a 30 and 90 meter resolution. Your Landsat is panchromatic is present in the 10 meter
It
resolution.
is just one band. In the Landsat 9, it is one band of 8 meter. And in the Sentinel 2, there is the 10 meter, but one band. So we cannot detect so much heterogeneity with one band. Thank you. Any other question?
Thank you for such a nice presentation.
Thank you.
You had presented the lithological units with the help of Aster
Yes.
data. Did you find any fault pattern or dip pattern in this data by using this Aster?
Simply my target is to identify or to map the lithological variation, and it is basically my first objective, and which identify the lithological classes like carbonates and clastic, red clastic, green clastic. But in my second objective, I am going to target this lithological variation at the more finer scale. Like I will map the carbonate of the Kohart limestone separately and the Shekhan separately. And structural in this very study, it is not under my concerns.
Okay, no issues. Thank you.
Thank you.
Okay, thank you. This would be the end of the session.
Thank you. Thank you.
I would like the distinguished chairperson to please give the shields to the presenters and their co-authors. First of all, I would like to invite Mr. Ali Iqtidar and Mr. Hafiz Zaman to please come and collect their shields from Dr. Khalid Amin Khan. Mr. Ali Iqtidar. And Mr. Hafiz Zaman. Next, I would like to invite Mr. Ijaz Ali Halipoto and his team to please come on the stage and receive the award. Mr. Ijaz Ali Halipoto. Mr. Abdul Shakur. Mr. Ali Ghulam Sahito. Miss Suraya Bibi. Mr. Rafiq Ahmed. Suraya Bibi. And last but not the least, I would like to invite Mr. Numan and his team to please come on the stage, which includes Mr. Numan, Mr. Muhammad Suleiman, Mr. Tala Mehboob, and Mr. Muhammad Shahab. I would now like to request Mr. Muhammad Ma Siddiqui to please come on the stage and provide a memento to Mr. Khalid Amin Khan. I would like to request Mr. Irfan to please receive the shield on behalf of Dr. Sajjad Ahmed. Mr. Ashraf, if you please can come on the stage and अरशद साहब प्लीज़ आ जाएं स्टेज पे और खालिद साहब आप भी आ जाएं चारों एक ग्रुप फ़ोटो भी आप लोगों की होनी है इरफान साहब यू हैव टू प्लीज़ वेट एक तस्वीर कर लें अरशद साहब के साथ और फिर आप लोगों की ग्रुप फ़ोटो है नहीं आपको देते हुए तस्वीर हाँ सर माँ साहब साथ ही रहे प्लीज़ हैव अ ग्रुप फ़ोटो आप चारों की एक ग्रुप फ़ोटो है जो है Thank you, sir. Thank you, Khalid sir. It was an honor having you here, sir. Thank you very much, sir. So, on this note, I end this session. And the next session will be, inshallah, tomorrow morning at 9. So, we officially close this session. One more announcement that all the presenters, all the authors, congratulations once again. The reviewers and ex-com members of PAPG are requested and the subcommittee are requested to please reach 1969 at 7 p.m. sharp because we have a shield distribution ceremony over there. So 7 p.m. is the time when the shield distribution ceremony will take place. So all reviewers are requested along with the ex-com members to please reach 1969 today. Thank you very much.